There we go. We are live and have a surprising lot of people today. And hopefully one of you will manage to have the internet connection going all the time. So anyway, welcome to Quarkus Insights 122. And we got a whole crowd of people. We have Holly, we have Martin, Matej, and Ladislov, which I'm sure will introduce yourself in a few minutes when we get going.
And Quarkus party.
It's Quarkus party. That's what it is. And as always, we have a topic this time, and this time it's I think this is the second round where we're doing stuff that's coming in. There's stuff happening in this area for Quarkus 3, and this kind of is like CDI Lite, which I'm gonna butcher and how I explain it. So I'm looking forward to a lot of stuff and the team to do this. But since we are on top of Quarkus 3, we released Alpha 6 last week. We had a bunch of fixes. And I know that we are ramping up for Alpha 7, or maybe even calling it Beta 1, because we're trying to get down to a CR1, is that a week or two from now? To try and get it in a stable state. And as always, the Quarkus 3 is the big move where we move from Java namespace to Java X namespace to Jakarta namespace. And so in the last couple of years, we tried to make migration easy. We continue to try, but this time it'd be a bit more rough because of the forced package change. So all these things are happening. So we're spending Quarkus Insights and all the good stuff that we know is great and stable and it's perfect. So this is CDI. I don't know, Ladislov, do you want to kick off and introduce yourself? And
sure, why not?
Talk about,
So hello, everyone. I'm Ladislov. I work on, in Quarkus, I work on many different things, including small rifle tolerance, Gendax, and also, as it turns out, the CDI implementation called ARC. With us are Martin and Matej, who are actually the resident CDI experts on the Quarkus team, and I'm just messing up with things they created. And today we're going to talk about CDI 4, CDI Lite, and most importantly, the build compatible extensions API that appeared in CDI 4. I do have a little bit of a slide deck, so if you can just turn it on.
We'll share screen. And I'll just say, as always, we have the chat going. So if you have questions about CDI or Quarks in general, because we have a big crowd today, so we can answer almost any question. Just ask them and we will feed them into the conversation. So back to you, Ladislov.
Okay. So as I said, the build compatible extensions API that we're gonna spend most of the time on came into existence with CDI 4. So the first slide I have illustrates the biggest difference between CDI 3 and CDI 4. CDI 3 is basically the Jakarta rename of CDI 2 that everyone knows and loves, and it has like a pretty simple structure, which is like the core CDI, the bulk, or the biggest part of the specification. On top of the core are the SE and EE APIs. What we did in CDI 4, among other things, was that we took the core and extracted or restructured it into two parts. Well, one of them is CDI Lite. It's like what I prefer, or what I like to call CDI the good parts, and it's like 90% of the core CDI. There's a few things missing from Lite, there's a few things that we intentionally didn't put into Lite. Those remain in CDI full. So Lite is basically a functional subset of CDI full, and if you're a Jakarta EE developer, you just don't have to care. But from Quarkus perspective, this is interesting because what we aim to implement is the CDI Lite specification.
Maybe you want to touch upon why this, why couldn't we just use CDI 3 as a? Because
Sure. So there's a couple things in core CDI that we didn't want to implement, such as specialization, and there's a couple things that we couldn't implement, which is the original portable extensions API, and that's like the biggest change. Why we couldn't implement portable extensions? Well, there's a couple reasons. One, to be able to execute portable extensions, you need to have a running CDI container. You don't have that. Sorry, I missed one important thing. The crucial difference between traditional CDI implementations such as Weld and what we have in Quarkus is that we execute the entire deployment process during application build. Right, so when the application is starting, the CDI container doesn't have to do almost any work. It's already deployed. Right. In CDI, in traditional CDI, portable extensions are a big part of the deployment process. And there's a couple of reasons why we can't execute portable extensions during build. One of them is we need a fully running CDI container. The other is it needs reflection, like the Java reflection API, which we don't want to provide during build, right? And there's probably one or two other reasons. I think these two are the most important. So what we tried to do in CDI 4 is to design another extension API for CDI, one that is, as the name suggests, compatible with this build time approach. It's also compatible with the runtime approach. So Weld has an implementation of build compatible extensions. Our Quarkus also has an implementation of the build compatible extension API. So like the interesting thing is CDI now has an extension API that can run during application build if the implementation is build time oriented.
Nice.
So we actually got a question here from Antonio. What I think is, does this mean that ARC will be a compatible implementation of CDI 4 Lite?
Yes.
Yes.
We are actually working on that. There's an issue on the Quarkus issue tracker with links to pull requests and everything. We currently have a sizable exclusion list for the CDI PCK. I think it's like 50 test classes, something like that. And we're reducing that exclusion list as we speak. So the goal is for ARC or Quarkus to become a CDI Lite compliant implementation passing the respective part of the TCK.
And I remember we had Martin, who's on here too, explaining like what ARC was, right? So ARC is the implementation for CDI that we have in Quarkus. And one question back then was like, why didn't we use Weld? And that comes back again to the build time aspect of it. But I also know, and Martin, you tell me I'm wrong, like at the time, we also took some, so there's one thing was the build time, the extensions was one thing we said, yeah, we would like to have it, but we didn't actually see much use of it. So because it was hard and we'll break the C aspect, we just didn't do it at the time. And then there was other few like things we just didn't do because it wasn't used so much. But now, and I remember there was we had. I'll put the link here to the what's it called, the YouTube, where it actually is. We've now implemented a lot of the missing features that there was in the first version of Arc, and the only thing that's left is the build time. The portable extension stuff. So
So you are right, and the truth is that we actually added a lot of the features that were not implemented in the first versions, like decorators and things like that. But we also added a lot of non-portable or features that are not part of the specification as well. And there's also one question in the chat from Anbu, whether can Arc be used outside of Quarkus application? So in theory, yes, but you would need to do the integration yourself, because currently we only integrate Arc with Quarkus, and we have some testing stuff to run the tests, but there is nothing like an official Maven plugin or anything.
Yeah, I'd just like to point out to this topic that one of the core design decisions in Arc that I learned the hard way is that the type discovery phase is implemented outside of Arc. So whenever you embed Arc, you have to run type discovery yourself. That's like the hardest part of it, I think.
Yes, you are right. Except that type discovery in this case means that you need to build a Jandex index.
Right.
Which is the source of information for Arc.
Right, but if you want to be like a full CDI implementation, you have to pay respect to the Beans XML files and probably a few other things.
But exactly.
And this again highlights this one of the things that I know people like. They don't necessarily appreciate a small little like what implications things have, right? Because when we built Quarkus, we realized a lot of the stuff that Java is spending time on, like triple goal frameworks, is doing the same thing 27 times. And one of those is discovery of classes. Oh, Hibernate has to scan classes, CDI, etc., etc. And I know in JBoss middleware, the app server, we had the same thing of reducing, and Quarkus just kind of goes to extreme, which is put some limitation, but it also gives benefits of like performance and reliability and that kind of thing. So there was another from Anton. I'm not sure if this is for now or later, but will there be a limitation to CDI 4 build time in comparison with classical Quarkus?
Yeah, I think Ladislav will touch on this a bit later, but just to quickly sum it up, there is like the CDI extensions are made in a way so that they only operate on CDI-related stuff, whereas Quarkus has an open-ended API and can do nearly anything that you want to do with it via both items.
I think when we get to this, like, I think it's important to say that a portable extension is not the same as a Quarkus extension, right? Those are not the same thing.
When speaking about portable extensions, we mean the CDI extension API that has existed since CDI 1.0.
And a Quarkus extension has stuff like native support and dev UI and dev service and all that stuff is not a thing.
Basically all the guts of the framework are exposed for the extension to alter, modify, or at least observe.
Hi. Well, you go back.
Let's go on. So as we mentioned, like the biggest thing that's missing from CDI Lite is portable extensions. And as a replacement, we have a new extension API called build compatible extensions. So it like in principle, it's actually fairly similar to portable extensions in how it's written and how it's used. So to write a build compatible extension, you create a class that implements the interface, and you create a meta-inf services file for the interface. right? And then what you do, you write a bunch of methods, and those methods are annotated with one of the extension phase annotations that are written over here. And there's actually a one-to-one connection between these annotations and the portable extension events. So I don't remember that, and I don't have it written down. But for example, the add discovery phase roughly corresponds to the before bean discovery event in portable extensions, and there's a lot more to that. So we've got discovery, which allows you to register additional beans, and it allows you to register CDI meta annotations like custom qualifiers, custom stereotypes, custom interceptor bindings, and custom scopes. The enhancement phase allows you to do annotation transformations. Basically, you can alter the CDI containers view of the classes in the application. This is like very common thing to do. This is how most frameworks do their work in one way or the other. We've got registration, which allows you to observe beans and observers that exist in the application. We've got synthesis, which allows you to create custom synthetic beans and synthetic observers. We'll see we're gonna see actually all of these phases in the demo. And we've got validation, which allows custom validation of the deployment of the application, basically. Right. So I'm not gonna spend more time on this because I'll show everything in the demo. One other important thing is that I said before that portable extensions require access to reflection. Clearly, there needs to be something like that in build compatible extensions as well, because how else can you inspect the application? How else can you know what classes are there and what methods are in each class and what annotations are there and everything? So where portable extensions use reflection, build compatible extension use something we call the CDI Language Model. For people who are familiar with Quarkus, the names here look familiar. It almost looks like this class hierarchy is Yandex. The truth is that the names are inspired by Yandex, and a lot of the API surface will look familiar, but there are notable differences. So, but the purpose is the same. This is an API that represents the application classes, their methods, fields, and notably annotations.
So can you maybe explain, like, for people who don't know, like what Yandex is, and B, well, don't we already have this in the JDK that you can get type information? Why do you need?
So JDK gives you the core reflection API, which has the classes such as JavaLang class, JavaLang reflect method, JavaLang reflect field, and there is also a hierarchy of classes that represent various types. In Quarkus, we don't use reflection. First, because it wasn't originally possible at all to load application classes at build time to the JVM. That actually is currently possible, but still we don't do that because it's got various, let's say, issues. First of all, it expands the memory footprint. If the JVM would have to load all the application classes to be able for us to be able to work with them, that wouldn't be very efficient. Second, if you load a class into a JVM, you will very likely execute the static initializers. So you are basically welcoming anyone to execute code during Quarkus build. Again, we don't want to do that. So instead of core reflection, Quarkus uses Jandex, which is basically we usually describe it as offline reflection library. What it actually does is it parses Java bytecode and creates a representation of that in a very, very efficient format, basically. So we can look at what classes the application has without actually having to load those classes to the JVM. Right, so as I said, the common thing to do in portable extensions is reflection. What we do in Quarkus is Jandex. Other frameworks use their own thing. For example, frameworks based on the Java annotation processing API use the JavaX Lang model classes. In CDI, what we did is, well, we created an abstraction that can be implemented on top of all these APIs. So this CDI language model can be implemented on top of reflection, on top of Jandex, on top of the annotation processing API, perhaps more. We actually already have an implementation on top of reflection and an implementation on top of Jandex. Yeah. So we've got an extension API, we've got a language model API, so that we can actually, so that those extensions can actually look at the application. So why don't we build a simple extension?
Sounds like a plan.
Cool. So what I have here, and there's a link to the demo later in the slides. So what I have here is a simple, I call it framework, but it's a very non-realistic framework that will show a lot of the typical CDI integration concerns. Right. So the framework has an interface called processor. The application is supposed to implement this interface. And then the framework, well, there's in this particular framework, there's nothing that calls those processors that would happen in the real world, but the framework still, excuse me, the framework still has interesting guarantees. For example, each implementation of the processor will be intercepted. There's an interceptor binding annotation and an interceptor implementation, which are not very interesting in this particular case. There's just logging, but there can be whatever, anything. This is actually from a real world Quarkus issue, which was opened a few weeks ago. Someone asked how to make sure that all implementations of an interface are intercepted. So it seems pretty interesting. So that seems pretty interesting use case and a simple use case to demonstrate here. So the framework will make sure that all implementations of this interface are intercepted. There's a simple class that allows access to all implementations of the interface. There's nothing really interesting here. There's no extension. It's everything just normal CDI. There's an annotation called important, which somewhat modifies the behavior of the logging interceptor. We'll see later why what this thing does. Right. So this is like very non-realistic, but it allows showing certain pretty interesting things. So, and I've got two extensions that integrate this framework into Quarkus. One is based on CDI Lite build compatible extensions. The other is simple, or, well, not simple, is an ordinary Quarkus extension. So let's take a look at the CDI Lite extension. As I said, the extension is an implementation of the build compatible extension interface together with a meta services file. Right? There's nothing really interesting here. So, and this extension just shows all the phases that I listed before. So in discovery, we make sure that the CDI container knows about all the classes it needs. So this archive doesn't have a beans XML, so the classes are not beans by default. Therefore, we have to, and this is like typical for CDI extensions. CDI extensions typically don't carry a beans XML file, so, and instead they participate in being discovered through the extensions. So here I add to the CDI container 2 additional beans. One of them is the logging interceptor. The other is the processor manager. This is fairly common for CDI extensions to do. The other thing is enhancement, aka annotation transformations. So here I'm saying that I want to enhance all types that are, let me scroll here a little, that are either processor or subtypes of the processor. And the way this works is fairly similar to how portable extensions work. This method will be called by the CDI container for each type that matches the annotation. Then the method declares the class config parameter, which allows me to do the annotation transformations. So I'll just take a look at all the methods of the class, figure out which one is the one prescribed by the interface. It's called do work, and it has no parameters. And I basically add an annotation on the method. Now, I actually don't modify the bytecode of the class or anything like that. I'm merely altering the CDI container's view of the world, right? So the CDI container looks at the classes, and on top of those classes, it actually has its own layer where it stores all the annotations. The CDI is mostly driven by annotations, so it has this layer on top of the physical classes, and that layer is mutable. So we can run annotation transformations on that. And this is what I'm doing here. So without altering the class itself, I'm telling the CDI container to behave as if this method was annotated. This is super simple in concept, but it's super powerful. And I mean, if you have any questions, or if there's a question in the chat, please interrupt me at any time. Further, cool. Further, there's the registration phase, which allows me to observe the existing beans. Again, it's called for each bean that matches the annotation. So here we'll get called for each bean that has processor as one of its types. I'm not doing anything interesting in this particular case. I'm just remembering what processors we have. I'll use that in a bit. After all the processors are registered, after all the beans exist, we can go to synthesis, and this which is the only way to transfer information from the build process to the eventually running application. So I didn't know how to demo this thing, but I knew that it's like super important. So I came with the important annotation. What does it do? Well, all the processors that have the important annotation are handled somewhat differently. And I want to know at runtime what processors are important. Now, I could take a look at the annotations through reflection, but for the purpose of this demo, I do something slightly different. I collect all the important processors during build in the extension and create a synthetic bean that at runtime will be able to tell me if this is this processor class important or not. To do that, I have an interface called importance, which just tells me if a class is important or not. And I create a bean that implements this interface and has the bean type of importance. The implementation class is called importance impl, and it's got nothing interesting, just a set of strings that correspond to the class names. So what I do here is I take all the processors I remembered during registration. I take a look at all of them that are marked important. And I create a string array. Note that this is still in the extension during build, right? So here I have the build time knowledge of all processors that are important. And when registering the synthetic bean, I can pass a parameter, which is in this case is called important processors. The value of that parameter is this string array. And now the magic happens. I also say that at runtime, an instance of this bean should be created using this synthetic bean creator. So this synthetic bean creator has access to the parameters that were defined in the extension. And the magic of build compatible extensions is that we make sure that when the CDI container calls this bean creator at runtime, it will have access to the parameters that were passed to it during build. So this is fairly simple concept, but it requires somehow a little bit of a mind switch, or how could I say it? Needs to you need to think about it a little before using it first. Then it becomes natural, right? So what happens at runtime? If I look back at the framework, the interceptor, which I have, will inject a bean of type importance, and we'll use it to determine, in this case, the log level. Right. So the bean importance here doesn't have a managed bean, or it doesn't have a class that is annotated application scope or whatever. The bean here is the bean that will be injected here is created here using the synthetic components API. Right. So this is we'll probably have to revisit that, but because the synthetic beans concept is a little bit strange, but it's extremely powerful.
I would add that for people familiar with portable extensions, this is basically adding a synthetic bean in the after bean discovery event through configurators and such. This is very much the same. You just have to keep in mind that we have separate build and runtime in Quarkus. So transferring state is not a trivial task in this case. And that's why we do these extra steps.
Yeah. By the way, you can basically transfer. So there's a limited set of types that can be transferred from build time to runtime as these parameters. it's basically annotations. And annotations can have primitive types, strings, enums, classes, and arrays of these. And this is exactly what we can pass here. So we can pass annotations from build to runtime.
And I guess what you're talking about here is actually the big reason why we couldn't just like retrofit the old CDI into this new one, right? That before you could literally transfer anything over this wire, because you were in the same JVM and you were spending the time every time. Here we now have literally like it's like instead of in one process, we now in two process.
Yes.
So how would you like? So you can transfer JSON over this string. You can't transfer complex objects, and that's the big thing that is different.
Yes.
So yeah.
Yeah, you can basically like with portable extensions and like traditional CDI, the container when it's booting has to execute all the extensions, and when you're starting the application 10 times, you have to run the extension 10 times. Here we run the extension once, and then we can start the application how many times we want, and the startup doesn't repeat this work.
Yeah,
that's what this build compatible extension API is supposed to enable.
Yeah, and what actually happens if you pass in types here that doesn't fulfill? Does it fail hard or?
No, you can't, because it's all statically typed. But then if you were to, I don't know, if you were to, for example, you can pass a class info or an annotation info, which are CDI types. If you try to pass a custom implementation of one of these, you will get an error. This is not supported.
Yeah. Okay.
Cool.
So, and the last thing, I think this is, well, we'll see how it goes, but the people will, like what I'm seeing here is that even if you are building, so let me say, if you are building if you are having a classical CDI 3 portable extension, I guess you could just encode whatever state you normally have in this phase, and then restore it on at runtime. And
yes,
you should be able to fairly quickly port over your
that's
assuming you don't do weird things.
That really depends on what the portable extension carries as a state. I have seen portable extensions that open sockets and read from files and start threads. That won't work. But if the extension only collects metadata for the framework, then those metadata typically can be retrofitted to annotations, and then you can pass those around.
Okay. We got a question here who's saying, like, how does all this play with being compiled to native image?
Yeah, the point is that there is nothing that could fail native image compilation here. We run this, right? We run this during build. Some of it will likely be executed in static init, probably. I'm not entirely sure now, but most of it will run during build, and will end up as just plain old bytecode that native image compiler will just compile. And then all these creators that they will execute at runtime when the CDI container needs to instantiate those beans. By the way, in addition to synthetic beans, you can also register some synthetic observers, where you'll pass them a class of a class that implements a certain interface, and that will be instantiated at runtime, and the event will be delivered to that instance. So you can do observers as well.
And I think this is again, this is one of like, let's say, I'm not saying complex because it's fairly simple once you understand it, is you could take most CDI 3 portable extensions and extensions in general and get them to compile and run with native image. Like, so if they are good citizens, they'll probably work. But they will run on every startup. They will have to rely on certain things. And what we are doing here is we are making a more explicit contract in CDI that makes it, hey, here's what you can do at build time, and here's what you can do at runtime. And that gives us, not only makes it even easier to be native image, but it also makes normal JVM mode faster because we don't have to do the 10 times init. And I think that's what people, I just want people to, not forget, remember that even though Quarkus came on the field like, hey, we want to do native image because it's great for like certain use cases, that's true. But the approach Quarkus takes is not just to get native image, is to also make JVM an efficient and quick thing. And that's the thing that we are kind of, going against the normal 25-year. Yeah, but well, we can all do stuff at runtime. We just need to be a bit more efficient. And we were like, yeah, you can, but how about we just stop doing stuff at runtime and then just ignore the whole problem?
Because the need to do stuff at runtime was from a world where we didn't have containers. And now that we have containers, you're almost always going to try just respin your container rather than trying to patch it dynamically at runtime. But we're still paying the tax for all that dynamism that we're not even using, which just made no sense at all. And that's what we fixed in Quarkus.
Exactly.
Yeah, that's right.
Cool.
And let's finish this one, and we'll show the exact same thing as a Quarkus extension. So yeah, the last thing is custom validation, where what we do here is we, at the very least, we validate that at least one processor exists. Right? So we again use the set of processor that we remembered here during registration, and if there's nothing there, then we fail. Right? We emit an error, and when you emit an error, the deployment will eventually fail. Right. So this is like these 5 phases are what's there. That this is like the bulk of the build compatible extensions API. Quarkus extensions have a little bit more than that, but these are the most important things. We anticipate that some other things, such as injection point transformations, for example, will be added to CDI later. So far, we have these 5 things that I believe cover like 80, maybe 90% of extension needs. Okay, so let's take a look at how the Quarkus extension looks. It's actually very, very similar. I mean, if you see the left panel, you'll see that I have a very similar, very classic Quarkus extension with the runtime module, which basically contains a recorder. We'll get to that later. And I have the deployment module, which has a processor class, which is common in Quarkus. So what I have here is, well, I have a feature which is like a Quarkus thing that advertises that an extension exists, and then I have a bunch of build steps, and each of them roughly corresponds to one of the extension methods here. So let's take a look at this. I will register additional bean classes over here, which is like exactly the same as I did at Discovery. This is pretty familiar. Excuse me. This is fairly common for Quarkus extensions that have anything to do with CDI. They very often register additional beans. The interesting thing here is the second build step, which produces the annotation transformer build item. This is exactly the same thing as the enhancement method here, except in a slightly different API. The annotation transformer API in Quarkus is basically a callback that will be called for each element whose annotations have to be retrieved. So it's somewhat hard to write, but it does the exact same thing. And again, this is fairly common for Quarkus extensions to do if they have anything to do with CDI. Finally, we've got the synthetic bean creation. What I do here is, again, pretty similar to what I did in the CDI extension. The Quarkus API gives me provides me with a stream of beans that exist in the CDI container. I can filter it, so I want only one class beans with the bean type, and only ones that have the important annotation. I'll figure out what those important processors are, and I can create a synthetic bean very similarly to what I did in the CDI extension, except I don't use a dedicated interface for creating the bean at runtime. That's also possible, but what I'm doing here is I'm using a recorder, which is the Quarkus native, one of the native ways in Quarkus to pass data from build time to runtime. I mean, we could probably spend an entire Quarkus Insights episode on the recorders, so I'll just skip this here, but it's super interesting. Yeah. The last one is. Go ahead.
Explain this one, and I'll go afterwards. Yeah.
Okay. Yeah, I just wanted to say that the last build step again is similar to what I did in the CDI Lite Extension. The validation phase gives me access to the set of beans that exist. And if I figure out that there's nothing there for the processor interface, I will produce a validation error. Right, so this example is a little contrived to make a one-to-one correspondence between the CDI Lite extension methods: discovery, enhancement, registration, synthesis, validation, and build steps in the Quarkus extension. But all the important concepts are here. We've got additional beans for participating in discovery. We've got annotation transformer for altering metadata. We've got synthetic beans and also synthetic observers to pass data from build time to runtime. We've got custom validation. As I said, the Quarkus extensions allow a bit more. There are more features than in the CDI extensions, but again, the core things, the most important things, are pretty similar. Go ahead, Max. What you wanted to say?
Yeah. So just to understand correctly, right? So the first part you showed how to write a portable extension using pure CDI.
Mm-hmm.
And then you said, here's how to write the same extension but using the Quarkus API.
Yes.
So I guess the interesting part would be, do we have any recommendation of, hey, when should you write a port? Because with this, you could be able to write a portable extension that runs.
I have a slide on that.
Okay, cool. Because I was like, it seems like that's a perfect match of, you can have an extension, Quarkus extension that expands what you do.
Yes.
Rather than having to rewrite everything. Yeah.
Right. So I mean, I'd first at this point, I'd like to ask if there are any questions regarding what we have just shown. And after we answer those questions, I'll move back to my slides and we'll answer just this question.
So we've got another one. Holly, do you want to take that one from Antoine?
I can have a attempt, although the others might. Shall we bring it in?
Sure.
Yep. So Antoine's got another question about, with the addition of CDI build-time compatible extensions, can we say that Quarkus is now a MicroProfile 6 implementation, or is it still lacking some features? And my understanding on this is that there's a divergence of opinion about the micrometer versus the, what is it instead of micrometer that's in MicroProfile? I think we don't, is it the
MP metrics?
Yes, thank you. Yes, the MP metrics versus micrometer, and I think Quarkus uses micrometer. So then that means that it doesn't have the full specification completeness on MicroProfile.
Yeah, I'd like to add on that. Quarkus still has an implementation of MP metrics, though I'm not sure if it's like formally deprecated, but it's discouraged at least. So that is there. And then when you use Quarkus small array metrics instead of micrometer, the question of compliance with MicroProfile platform becomes a matter of compliance with CDI. MicroProfile, as far as I know, in the latest version requires a CDI Lite implementation, which Quarkus currently almost is. We are not passing a few TCK tests, so we can't claim compliance with CDI yet. And therefore, we can't claim compliance with MicroProfile, strictly speaking, with the MicroProfile platform. We are compliant with all the individual MicroProfile specifications, not with the platform, because we've got a few more CDI TCK tests to fix. I think that's my take on this.
Cool.
Yeah. Matej, other comments? Otherwise, I have a comment on this.
I think Ladislav pretty much said it right. I'm not entirely sure that. I think you're right that they switched to CDI Lite as the requirement for it, the minimal one. And build compatible extensions are one of the reasons why they could do that, because now the libraries have a way to integrate, a standardized way to integrate a CDI. But we're getting there. We're not quite there yet. I can't really comment on the metrics versus micrometer that I'm not familiar with that much.
Yeah. So just for people, it's a moving target, right? So
yeah,
we are doing everything we can, but we also don't want to recommend people things we don't want people to use. And one of them is not micrometer, but the MP metrics. And this is actually a discussion we've had since a long time. I just put a blog in here on Quarkus.io. I think it was published back in 2020. And this comes out of that MP metrics has one approach. And it's just not, it has some issues. And therefore, we looked around. A micrometer is just used by everyone else in the ecosystem. And it just seems like, hey, we can do this much better and reliable than the MP metrics one does. And that's why we are here. So yeah, Quarkus will not by default use MP metrics. He'll use micrometer. But yeah, we'll see how far we can go. But if you want to do MP metrics, you can. But yeah, we don't recommend it. So
I actually think that we don't have the latest MicroProfile metrics specification has changes that we don't implement. I think we don't have the latest, very latest, because we just believe micrometer is a better choice.
Yeah.
Okay. Right. Do we have any more questions on this, or should I?
Nope. You can go. Go ahead.
Okay. So I'll move back to my slides. I've got a little bit of a comparison here between Quarkus extensions and build compatible extensions, just to summarize what we have seen. So Quarkus uses Gendex as the language model. If you want to inspect the application classes, you will use the Gendex API. Build compatible extensions have their own abstraction. They are similar, but they are not identical. On a more general front, the Quarkus extensions can use all the build items there are, and there are hundreds of them. So you can integrate with anything and everything in Quarkus. On the other hand, the build compatible extensions only have a fixed set of extension points targeted at integrating with the CDI container and nothing else. The ordering of execution in Quarkus extensions is driven by the produced and consumed build items. In CDI build compatible extensions, the ordering is fixed. The interactions with the entire environment is unlimited in case of Quarkus extensions. You can combine build items from anything and everything. If you have a build compatible extension, you only have a very restricted set of interactions with the entire environment around you. Finally, as I said, well, you can affect anything and everything with a Quarkus extension. With build compatible extension, you can affect just the CDI container. And so these are like the obvious differences. With one last thing on top, if you write a Quarkus extensions, you're obviously targeting just Quarkus. If you write a build compatible extension, you are targeting all CDI 4.0 containers out there. And if comparing these differences, it's pretty straightforward to come to a recommendation that if you're writing a CDI-based framework that you want like portable across all CDI implementations, you will probably want to write a CDI extension. If you want to target tight integration with Quarkus, if you want to customize your framework for native image compilation, if you want to do bytecode magic, bytecode transformations, and basically have all the power that is available, then you will obviously want to write a Quarkus extension. It should be fairly easy to combine these. You can write a CDI build compatible extension that does the minimum required work to integrate your framework. And then you can write a Quarkus extension on top of that to say, let's say, sprinkle some native bits here and there, if you want.
Close the gap. Yeah.
Yes. Yeah.
Are there packaging differences? Like, is there an implication for one would be easier to package, or one would be easier for things to consume, or is it in both cases do you just make a dependency and then depend on the thing that? Well, sorry, you make yes. You
yeah,
make
if you are an extension writer,
yeah.
If you are an extension writer, then well, clearly, Quarkus extensions are a bit more complex because they have, or they usually have, the deployment module and the runtime module. It may happen that the runtime module sometimes is empty, but typically it's not. You have to use the Quarkus Maven plugin or the Quarkus extension Maven plugin to generate the metadata and everything. So like, but that's like one-time cost usually. While on the other hand, the CDI extension is just a single archive with no magic at all, no descriptors except the meta-inf services file. So really, what I would say is my Quarkus extension is maybe a little bit harder to set up when you're starting, but that is excuse me, you get a lot more power for that in return.
But I also think you could also just treat this as today, like today, until Quarkus 3 with this comes out. Already today, we have people making extensions for CDI stuff, right? So
yes,
this is just there before everything was in the Quarkus extension. Now you can move some of that logic into where the library is in itself.
Yes, could be.
And therefore, I don't think that this really, it's not an either or. It's just like, oh, now instead of, I don't have to do it in a Quarkus specific way for a lot of things. I can just put that into framework. It's all good, and every CDI compliant framework will work. And then in Quarkus, you have stuff like, set out dev service, do some tweaks for native compilation, do test integration, or do some additional stuff of, I want to go beyond CDI, right?
Yes.
But I think it's instead of saying, hey, you do either or, it's just, hey, some of the code you before always had to do in a Quarkus extension, you can move into the framework. And now what's left in the Quarkus extension is stuff that is just,
Just want to say that we're not like deprecating anything in Quarkus. No build item related to CDI is getting deprecated or removed or anything. This and if you have a sizable Quarkus extension that like integrates very deeply, you might want to use the Quarkus extension even for the CDI bits. I think that would be my general recommendation. If you have something that's based on CDI and you don't have a Quarkus extension or don't need a Quarkus extension or only need a Quarkus extension for a very few tiny things like native compilation, then it's a good idea to use CDI extensions. If you are integrating deeply with Quarkus and have a big extension, you will probably want to use the Quarkus extension even for the CDI bits.
Before you only had a choice of one hammer, and now you've got a choice of two hammers, and the Quarkus extension hammer is a bigger hammer, and sometimes you want the big hammer and sometimes you want the little hammer, or you could start with the little hammer and then use the big hammer.
Yes. Yeah, very well said. I agree totally.
And meanwhile, your code is the nail.
Yeah, and here's the link to the demo that you can use to play with this. All right, and that's all I have.
Awesome. Any other comments or questions? Matej, Martin, Holly?
I might just add that some of the use cases for build compatible extensions are for frameworks that, for instance, are used in different environments, such as in Jakarta world as well as in Quarkus world. Some of the small RAI projects come to mind, and those can now effectively use build compatible extensions as a way of integration. And there is a single extension that will work in both in Quarkus world and in the EE world that uses a runtime implementation such as Weld, for instance.
Awesome. Yeah. Very cool. Okay. We'll give it a few minutes if there are any questions. Otherwise, we are over time, so that's cool. Okay. Well, Ladislav, Matej, Martin, and Holly, thanks for showing up, and for everyone else listening in and watching this. We'll see you next week, and good for this. Thank you.
Thank you.
See you.